Hi everyone. So in this lesson, we are going to introduce the classes, mainly the object-oriented programming. So let's start with the structure. So structure is also a user-defined data type, struct. And let's see an example of struct, which is a circle. And circle, as we know, can have a radius. And let's say that it has another attribute, which is a color. And color is a string type, radius is a float. So this circle is a user-defined data type that can have two further attributes. So the structure allows creation of user-defined data types by aggregating multiple data members. So what we are going to do here is we are aggregating the multiple data members. So we have one data member radius, second data member color, and we have aggregated to create a new data type which is called the circle. So it simplifies the data management and groups the related data together because both the data types, radius and the color, belong to the circle. So now we have grouped and created another data type circle. And whenever we need radius or color, so we can refer it using the dot operator. So each C++ variable, as we know, has a type, and this type is the circle is another type that we have created. It is in addition to the primitive data types. If we want to create an object of the circle, so we have a circle here, and now we can create a object of circle like this one. So this is the object as we create the variables, and there we write the data type as we write for the value. So this value is a variable of type integer, but here this circle is of type the circle. This circle is a type of this circle. As we know, we have the primitive data types, and standard type library has number of other data types also, like size t and the string. And now we are talking about a user-defined data type. Let's see another example. Point, as we know, in two-dimensional, if we consider two-dimensional, then the point is represented by the two axes, x-axis and the y-axis. So each point has two numbers. One is associated with the x and other is associated with the y. So that is why we created another data type which is called the point. And if we want to create an object of point, so we can write it as a point and then the point here. And we can assign these values. So for example, here we have not assigned the value that what should be the x and y, not initialized, but we can assign it now. So we can say the point dot x. So this is how we access this, because x and y are the member variables of the new data type that we have created, the point. So if we want to access the member variables, we'll use the dot notation. So we have created a, you can say, the variable or the object which is named as point, and if you want to access x and y, so it is the point dot x and the point dot y. And we are using here the assignment operator, not the braces operator initialization. The reason is that the object has already been created, and once the object has already been created, we need to use the assignment operator. We can't use the braces. And then you can display the values of the point. Then it will display the values that we have initialized, 5.5 and 3.3. Now, if you see that if we don't initialize here, then what's going to happen? So we still have the same x and y, and we created an object of type point, and then we print. So it's going to give some random values. So we need to always ensure that your program is in stable state, and whenever you create a member variable, make sure that they are into their default values. So what we'll do is we will write like this one. So we have double, and we'll initialize x and y. So whenever an object is created of type point, so x will be initialized to 0 and y will be initialized to, or whatever value we want to initialize. So our the policy is that the program should not have an undefined behavior to prevent any potential errors. Access control. So we can have two access control for for the time being, and then we will have other access control later. So access specifiers can be the public and the private. Public means the members are accessible from outside the class. So outside the class means that a class started with this scope and ends with this scope. So can you access the data members here or not, which is outside the class? So if the members are declared here as public, so it means that these can be accessed outside this scope. So if it is privately declared here, then you can't access it outside. Members are, if it is private, it's accessible only within the scope, not outside the scope. And the default access, if it's a struct, then members are public by default. And if it is a class, then members are private by default. So this is another example of struct. So we have IOStream and assert. So we created a point, and it is x and y. So we have initialized x and y to 0, and we created another object point, and then we can check whether these two values are same or 0 or not. So this will be, both will be true. So point.x will also be 0 and point.y will also be 0. If it is a class, then we just change it to the class here. It's still the point, but now class is a point. As we know, the default this is default, and default in the class is private, while in this, if it's a struct, default is, so this is public by default. So since it is public by default, it means that we can access here. So the scope starts here and the scope ends here, but we can still access x and y outside this scope because these are public. However, here the default is private, so scope starts here and ends here. So if we try to access here, so this is going to give us the error. So we can't access this. So there are other ways to access the variables, but if the variables are private, so outside this scope, the variables can't be accessed. So that's the scope ends here. So if we want to access the private members, so what we need to do is we need to define the accessors or mutators. So accessor is something, a function that can access the value. So its role is to return the value because it's a private data member. So it can't be directly accessed, but you can have a method, and that method can access the variable and can return the value to you. Similarly, mutator, the role of the mutator is to change the value. If you want to write the values, update the values, then you need to use the mutator. So here we have 4 functions. That's our first function is capital X, and this is also capital X, and this is capital Y, and this is capital Y. So why we have 2 functions? So there is a difference here. In the first X, we have a parameter here, which is the int X, but it does not have an parameter. So these are 2 different functions. Similarly, Y also have integer Y, it accepts Y, and in this Y does not have. So these both X and Y are different functions. So when this function is called, this function is called when we pass some value. So when we pass some value, it means that value is to write the value of x. So x. So when we call this x with some value, so this value will be written on the value of x. If it is 0, then you pass 5, so 5 will be written on the x. So that will become a value of the member variable. However, if we don't pass anything here, so it means that this function is not to write any value because there is no value being passed. So it means that it will take the second, you can say the second role. The second role is to return the value. So if you are not going to write the value, it means that you call this function to get the value. So it will return this underscore x. So then it will going to return the value of the x. Similarly, y. So if you pass the value of y, it will write that value. So if you don't pass any value, it means that this is going to return. So we can say that this method is what? So this is a mutator. because it updates the value, and this method is accessor. Similarly, this method is mutator, and this method is accessor. So for each variable, we can have one accessor, one mutator. Accessor and primary defines, yeah. So since now we have defined the accessor and mutators, so and this is a class or maybe a struct. So you can have a class or struct, whatever. So if it's a struct and then the variables are private now. So if the variables are private, means you can't directly access these variables. So we need to use these accessors and the mutators. Okay, now, so here we have a main, and we created an object point of type point. So we can say the point dot x5. So remember that we can't write like this one, point dot x is equal to 5 is not possible. Reason being that you can't directly write the x, but you can call point dot x, which is the capital X, which is a function, and we can pass 5. So this 5 will assigned similar to this one. So will 5 will be assigned to x. And similarly here also we call the y with the passing the value of 5. So 5 will be assigned to the y value. And if we'll check what's the value of x and y, so we still can't use it for checking also, but we can call x without passing anything. So this will return us the value of x, and which must be 5 if our program is correct. There is no other error. And similarly, the point dot y also must be 5 because we have passed the value y here. So accessors in C++, when to avoid them. So as you have seen, if we have two member variable, so if we have 4 functions, remember, just see that if we have few member variable, maybe 10, then we are going to have 20 functions for that, because each variable we need to have an accessor and mutator. So each must have 2 functions. So what are the C++ core guidelines? The core guideline recommend against trivial accessors. So what is a trivial accessor? That adds no semantic value. If there is no semantic value, then you can just declare that as a public. So instead of having the accessor and mutator, just declare that variable as a public, like in our previous case. So what we have done here is here. So what we have done here is that we have created an x and y, and x and y, the role of the x and y functions is to mutate and access and act as an accessor function, but they are not adding any value. So we have functions to do the same thing, but we could have done directly, the main could have directly written the values of x and y instead of calling these functions. So this is useful if we want to restrict some values. For example, if you want to say that this before mutating, we need to check that this x must be integer, maybe negatives not allowed, or maybe some higher than some particular values are not allowed. The x should range between -1 to 1, or it could be from 0 to infinity. So if we have some rules in place, then we can enforce those rules here, because otherwise in main we can't enforce that. So the only benefit of having the accessor and mutator is that if we have some restrictions to assign the values of x and y, then we need to write these. But if it's just a trivial, like whatever value is getting and just assign to this, and if it is asked, then just return, and you're not going to check whether you should return this value or not, then this is a trivial mutator and trivial accessors. So C++ code guideline states that these are not required. So you can read more on the link about the guidelines. So if data members are public, so in case, so you decide that data members are public now, so we are not going to have the accessors and mutators. So if you decide that I'm going to use the public, and these are the only variable that you have, then the best is that you should declare the struct instead of using the class. So because what will happen is then you will write like this one, a class, and then you will write point, and then closing brace, and then you will write here the public, and then you will write float x, float y. So you created a class, and then you are saying both the members variables are public. So what's the point of creating the class? So instead of creating the class, because when you see the class, it means by definition, by default, the people when another programmer will read, so it means that you want to create something private there, but you have all the variables public, so no point, you should not be creating class. Use the struct here. So we should not be using the class here. We should use the struct and keep the member variable as a, by default it's public, so we don't have to write anything that these are public, and then we can use the dot operator here. So this is a very short program without any accessor and mutators. We should write programs like this one, but only when it's trivial accessor and mutator. But if we have some restrictions in place, then this is not the best way. We can have constructors also in the structure. Like we have a point, we declare two variable x and y, and this is 0, this is 0. Then we can have a constructor here, and this constructor is another function that creates an object. So, and it creates an object with some values. So, for example, you don't want to assign 5 later, but you want to create an object with some default values. If that is the case, then we should define the constructor here, and constructor should not have any return type, and its name is same as the class name. And we have here, for example, it takes two x underscore and y underscore, two values here. So it accepts two values, x underscore and y underscore, and the values are assigned to these x and y's. So, and this is another way of assigning the values to the member variable. So this method is called, this is called the initialization list. Initialization list or initializer method. And the second method that you may have used is that we define the constructor point, and it takes the values integer x underscore, integer y underscore, and then here, which is currently it's blank. So this one, currently this is blank, but we are going to define like this one here. So we can say uh, x is assigned the x underscore, and y is assigned the, or you can say this arrow x is assigned the x underscore. So this method is called the assignment method. So where we receive the values and we assign these values to the our member variable. So that's one method. And the second method is initialization. So we have nothing in this assignment or in the block, but we use this method to initialize the value. And we'll talk about this later again. And another thing, that if we have created our own constructor that takes two values, and in case we want to use the default values, so then we can also say that point, and then if the point is created without any values, then we are going to use the default constructor. And the default constructor is that it will create an object with these values, what we have initialized. For example here, so we say point origin. So when say point origin, it means that we have not called the constructor here. So default constructor will be called, and default constructor will be called means that 0 values will assign, and we can check whether these values are indeed 0 or not. So we have origin dot x must be 0. So we can use the dot operator because this is structure and this is by default public. Similarly, we can create another object point11, and this 11 will be assigned. This constructor will be called now, and this x and y both will become 1. And we can say point dot x is equal to 1 and point dot x y also equals 1. Class and struct, when to use each. Classes allow us to group related data together. So the benefit of the class is, the convention is, you can use class or struct other than just by to tell that whether the variables are public or private, but the classes are mainly used when we have the related data. So if the data is not related, then we should prefer the struct. But if the data is related, then we need to prefer the classes. We need to use the class. So convention for use. So use a struct when member variables are independent of each other. So if we have two member variable and one is not related to the second one, it means that we should use the struct to tell our users that the member variable are not related, and there is no rules that we are going to enforce some rules to assign the values. So one can be changed without affecting the other. So we use class when member variables are related by an invariant. And what's invariant? It's a rule that limits the value of a member. So if you have a rule that limits the values of the member variable and they are related, so it means that we should use the class. In most cases, the class will be used. Let's say that we create a class here, and this class is a person. And this person has name. All persons have name, age, and height. And the default values that we have initialized is unknown, age is 0, not born maybe, and height is also 0 in meters. Now we have a public. Functions mostly will be public, and the data members are, if you don't write private, then also it's private. So we have a public, and now because we have a name and this is a private. So any name private means that we need to have accessor and the mutator, because the member variables, name, age, and these can't be directly accessed. So name, age, and height can't be directly accessed because these are private. So we need to have accessor and mutators. So we have a function called name. The same thing. If the name is receive some value, then it means that this is a mutator. But if name does not receive any value, it become accessor. So you don't have to write get name, set name. You can have that also. You can call this as a set name. You can call this as a get name, but the simple name is also sufficient. Okay, so you have a variable where you can keep variable in the small case, that name, and you can corresponding accessor and mutators can be the first capital and end capital, and you can say name, and the same function can be used for the accessors also, and this is the mutator. So mutator will receive a value name. So name is a string. So anything which is a string or any object, generally we receive its reference, so that another copy is not created. So it receives a value by reference. However, the name, this doesn't have to receive any value. Its role is to return the value, but it should not change the state of the object. So we are saying that it should be constant. So it should not change. Its role is, this is an accessor function, and the role of accessor is not to mutate. So we are saying this is a constant, and it should return. So and it returns a string. So this is the string that it returns. Similarly, we have an age function. So age function, this is again, this receives this age. This means that this is a mutator, and it returns nothing because its objective is to set this value of the age. So we need to check whether the age is at least greater than 0, and then we may also check that maybe it's less than 150 years. So we need to check those values. So we can enforce those rules. And similarly, this age must be constant because this is a accessor. This is mutator. So since this is accessor, all the accessor functions must be constant. So their role is to give the value whatever is there, state of the object. So similarly, we have a height function that receives a height, and we need to validate this function. Validate means that we need to enforce our invariant here. And when it returns, so it returns float and it must be the constant. So this is how we define a class. Means at a very high level overview, we will have a member variable, we will have accessors and mutators, and the accessors will, role of the accessors will be to return the value, and all the accessors will be constant. And the mutators will receive these values. The receiving value will be constant. So the name will be constant. Age you can keep as a constant, or because you are receiving by value, so there is no need to write the constant. You change it, whatever your the value is not getting changed. But if it is a reference, then you need to make sure that there is no accidental changes here. So better is to write the constant here. Similarly, the height is received by value, so you may not write it as a constant, because in any accidental changes will be affected changes here only, right? And so so this is the invariant for the name. For example, we receive the name, we are checking that this is not empty. So if it is not empty, then we are assigning this name. So by default, if it is empty, then it means that all the names will be unknown. Otherwise, the empty string will enter into our database. Okay. Similarly, if it is a name, then it's a constant. It will return the name. So whatever the value the name is, may be unknown or maybe something. So it is going to return that name. Age. Similarly, we can say if age is greater than or equal to 0, then we are assigning this age. In fact, it should be greater than 0, maybe 1 day. So it should be assigned. Similarly, a person with age and who will want to return. So we are saying here, return age. So the age will be returned. Height, if it is greater than 0, if there is some height, then we are assigning this. If height is 0, then we are not going to assign. It's already 0, or maybe negative, then also we are not going to assign. And this height function is going to return the height that we have already updated. Now we have a main function here. We created an object, which is the person object of type person, and we can say that person.name when we pass the empty string here. So what will happen here? So since we pass the empty, so this empty should not enter into our object for this person. So it should be unknown. Similarly, if we say -10 of age, so this should also not be entering into our database. When we say 1.75, which is positive, this should be okay. So if we will check here, after even executing this statement, we should get person.name must be unknown, even though we set -10 here. So age should return 0 actually. Or height should be not 0, but it should be 1.75 because that's the valid value. So this is the complete code. You can play around with this one. Next is encapsulation and abstraction. So what is encapsulation and abstraction? First is class. So we have a class here. So data and operation. So what is a class? Class is actually there is some data and some operations on the data, like we have name, we have age, or some other values are maybe there. So we have data. This is the data, and then we have the operations to set the name, to get the name, accessor and mutators, or we want to compute the age of the person. We can check whether there is the current year, and then we can subtract with the date of birth, and then we can. So those are some operations that we want to do. So we want users to use the provided operations to access the data and not directly interact with it. Not directly interact. So that's important. So what we want is that the users of this class, which are the objects, should not use the dot operator. So we have defined some operations, and those operations must be used, not directly interact with the data. And why we want this that they should not directly interact with data? Because we have enforced certain rules. So for example, the age must not be negative, age must not be 0, and the height must not be negative. So because those are the restrictions. If we directly access, then those values can be entered, like the space can be entered. So we want a name, not empty, rather unknown. Okay, so that's the reason that we want to give, we want to create the operations. Next, what is encapsulation here? Encapsulation is building the related properties together in a single class and protecting these properties from unauthorized or accidental modification. So now you have a property which is the name, which is the age, which is the height, and you have protected those properties by accidental modification because you have an operation there that does that, and that cannot be directly changed. So similarly, for example, if we are driving a car, we have a steering wheel that helps us to move this. So you can't directly, there is no other function. So if you want to move, then you need to do some of, use that operation, that handle, or anything else that's given. So we can use that. So similarly, here we have that's called the encapsulation. So all the properties are encapsulated there, and there is no unauthorized or accidental modification. And what is the abstraction? Abstraction is that user or class only need to be familiar with the interface. For example, here we have that set name or get name. So you need only those functions. In steering wheel, we need steering wheel only. So we are not concerned with how actually the wheel moves. So we should be knowledgeable about that interface. Without knowing storage or implementing how the data is stored, you're not concerned with that, whether it's on the static memory or in the heap memory. We are not concerned about that, or how that data, whether you're actually checking whether this value should be greater than zero or not. So that is also hidden from the implementation. I mean, hidden to the user. So users must know only the interface. That's the abstraction. So there is a level of abstraction. You don't have to be knowledgeable about all the implementation. Constructor. So constructor is a member function that can be of a class or a structure that initializes construction. Now, what do we mean by initialization? So that initialize constructs an object. It sets up invariant first, so it enforces certain rules and acquire resources released by the destructor. So it will acquire resources like allocating the memory to that object, and then that memory will be released by the destructor. So if no constructor is defined, let's say that you created a class, but you don't have any constructor, the compiler will define a default constructor. So compiler is going to create a default constructor, and that accepts no argument. So this will be without any argument. But if you want to have a constructor with the argument, then we need to define it like this one. So we have a person here, and this person has a name, age, and height, and this constructor receives these values, and these values are assigned to the member variable, which is the name, age, and height. So we can write this arrow name because the variables are same, so it doesn't look like, so if you're not writing name equals name, so we can write this name is equals to name. Or we can have N, A, and H. We can say name equals H, then also is okay. Okay, next is scope resolution. So in some cases, there may be a different variable in different scopes. So if that is the case, we can use the scope resolution. We'll tell that this variable is from this scope. And a number of times we'll use this in class. So we will define the class where there will be no implementation. We'll just have declarations only. And then we'll define the functions of the constructor, then we'll use this scope resolution operator to tell that this function or constructor is from this class. For example, here, so we have a person, and this person is a constructor that takes the name, age, and height, and we don't have any definition. This is semicolon here. And similarly, we have a person which is this has no it's not accepting any values, no arguments here. So here we are saying that if you use the default, so if no values are passed, it means then we'll use the default constructor. But if the values are passed, then we'll use this constructor, but we have not yet defined. So here we'll write that this person is from the person class, and it is accepting name, age, and height, and we are assigning these values. Similarly, we can also use the namespace globally group. So in order to group logically related variables and functions together, so you have variables and functions, and we can put all of those variable and function in one namespace, and we can create a number of namespaces. So it will also prevent conflicts between variable and function. So if you can have the same variable, same function in one namespace, and you can also have the same variable and same function in another namespace, and then you can use that namespace to tell that which function you want to use. For example, here, so we have a namespace savings. So savings is a namespace, and it has a function called account information, which is written void, and also a withdraw function that withdraws money. Okay, so this is also defined in this namespace, which is the savings. Similarly, we have another namespace now. This is checking. And now its scope is here to here. And this also has account info. And this also has withdraw. Exactly same function. Similarly, but outside the namespace, in the global namespace, we have again account info and withdraw. So we have three account info and three withdraw functions. And first is used for the savings account, second is used for the checking account, and third is used for all other accounts, right? And when you call these functions in the main, so you want to, if it's a savings account, you can say savings scope resolution operator account info. So when you call this, it means that you want to use the savings account, the account info, which is in the savings namespace. So when you say withdraw from the savings, it means that you are calling the withdraw from the savings namespace. Similarly, here this account info is from the checking namespace, withdraw is from checking namespace. But if you want to use the global namespace, then this is you need to use the general scope resolution operator. No need to write anything here. Just say double colon, and account info, and again colon withdraw uh, function. So this will use the namespace, and you will see here the savings account 1.5 interest rate, because this is a savings account, withdrawal from savings account, checking account no interest rate, and withdrawal from the checking account, and generic account information and generic withdrawal. So this is how you can use the namespaces. And we have already used the standard namespace, which is the feature of the C++ standard library, where everything is defined under the standard namespace. We have been using standard cout, using standard string, using standard vector, because these all things are defined in the standard namespace. Next, initializer list or assignment. So we have seen that we can initialize variable using this parenthesis, or the basis, or the assignment. So how? So let's say that we have a book here, and we have a string. This T is a string, and A is again an author, and Y may be the year. So we have a title, author, and year. So we are assigning this title to a member variable title. So one method is that you can write like this one. So you will use the parenthesis here, so title and then T, or you can use the braces method here, or don't use anything here and just use the assignment operator. But if you use these method parentheses, then this block is empty. This block is also empty, but here this block is not empty if you are using the assignment method to initialize these variables. Okay, so now what should we do? So C++ core guidelines prefer this initializer syntax, right? So we'll see why this is preferred. One of these is preferred. So you may see in number of books that parenthesis is used. In some books, you will see that this braces method is used, and this is used in some cases, as we will see the program. Okay. So this method is preferred because, as you've seen in the vectors also, we use this method, in arrays also use this method. So this actually gives an indication like this is title is a function. So but title is a variable here, and we should use this one. So the one thing reason is that we should, it gives an indication that you are initializing the variables. And we'll see why assignment is not, may not be a good method in number of cases. So now we're talking about whether you should initialize or assign. So initialization, what is initialization actually? Because assignment is also initialization. But what is actually initialization now using the initializer list? So initialize member variables before the class constructor runs. So this class constructor will run after that, but before that, the members will be initialized. So which is a good thing, that your object is created with these values. So initialization sets the value as soon as the object exists. However, the assignment, it sets the value only after the, so first the object will be created and then you will assign these values to the member variable. So there is a risk of using uninitialized variable. So you will not see the risk right now because the program is all sequential, but we'll see later on when we'll do the concurrency, when we'll create multiple programs, and then we will see what happens in that. So there is always a risk of uninitialized variable, because you know that when we run the program, it's not that you will get the CPU immediately. So there may be a delay of getting the CPU, and at that time some other program will try to read your code. So that can create some conflicts here. So that's why it is always best that when you create a object, you need to initialize immediately, so your object will exist with these values. So what is the best practices? Use initialization for arguments with no invariant. And other restriction is that you can use this method, or this method, which is, we call this as initializer, only if you don't have any rules. Like if you don't want to enforce any rule, then you can use this, because this is just, you can write the values here, that I want this T to be assigned to title. But if you want to check whether this is empty or not, then you need to use this assignment method. So if you want to enforce any invariant, then assignment. You can do both also. If there is a variable that doesn't need any rules, so or invariants, then must use the initializer method, which is best is this one with the braces. Right? And if there are invariants, then we are going to use this method, which is the assignment. Okay, so that's one. Use initialization for arguments with no invariant. Second, prefer initialization list over assignments in constructor. So if you have a constructor, then we'll prefer initialization list rather than using the assignments in the constructor. Third, using const with initializer list. So if you have a member variable which is constant, so now the constant must be initialized at some point of time. At what time it should be initialized? It can be initialized at the runtime. Okay, and then it should not be changed. So if there's a constant, but it can't be initialized once the object has been created. So if you have some member variable which is a constant, then you must use the initialization list, otherwise there will be an error, because this is a constant and constant must be initialized at the time of runtime. May possible, but at the time of the object is created, not after that. So class member variables can be declared constant. So your member variable can be constant if initialized in the initialization list. So if you have a constant, if you're going to initialize that variable in the initialization list, then you can declare that variable constant also. But if you are not going to initialize in the initialization list, then you can't declare that as a constant. So initializing constant members within the constructor body is not allowed. For example, this case, initialization versus assignment. So here we have a year, which is a constant here. So this is an example, and this is a private member variable year. which is constant now, and this value is a known constant variable. So we have a constructor here that takes the value y and v, and we are using initializer here. So maybe we can use the braces method here or the parentheses here. So braces is preferred, right? But we must use this method. We cannot use this method, especially for year. Value can still be here or here, but the year must be here in the initializer list. So writing like this one, year is equal to y, will give us an error. The reason for this one is that this is constant. It means that when the object is created, the constant value must be known at least at that time. It can't be changed after that. So that's another reason to use the initializer list. First, compiler optimization. The compiler can optimize initialization faster than from within the constructor. So compiler can immediately initialize rather than assigning the values that will take time. So object is created with the those values. So that's much faster. Second reason is constant attribute. So if you have a variable which is constant, then you have to use initialization list. This can only be initialized during that. And third, reference attribute. So if your member variable is a reference, so as we know, the reference must be known at the time of initialization. You can't have a reference later on, and you can't change that also. So if you have a member variable which is a reference, you need to use, then also you must use the initialization. So in this case, in the class case, you will see that we'll have a reference variable, but we are not initializing. Because we are using the initialization list here, like this one. So we have a reference variable, which is ampersand. Here we can see that this is a reference variable. It means that we have not yet initialized it, and which is perfectly okay. If you write a main directly, that it is going to give us an error because the reference variable must be initialized, right? But here, this is okay, perfectly okay, because we are assigning this value here. So we are saying that reference value assigns to R, and we are giving it in the initializer list, not here, using the assignment. So that's why it's perfectly okay to initialize reference variable later, but using the initializer list. So we have here, we're passing R and V, and we're assigning R and V here. And then we have another function which displays, and it's declared as a constant because its role is to display the values, not change those values. So it must be the constant. So we have a reference value, and this value is a display. So let's see the main now. We have an original value, which is 10. We have a value, which is 50. And now we called an object, created an object EX, and we pass the original value, and we pass the value here. So what's going to happen here? When we say display, it will display what 10, 50. Why? Because when this 10 and 50 is passed here, so this 10 it will become reference value, and this 50 will become the value here. So this will become 10, 50. And similarly, if we change the original value to 100 now, and the value also is changed to 100, then what will happen? Because the original value, which is the first value, is the original value, which is the first value, is passed by reference. So this reference will be changed, so it will become 100. But the second value passed by value, so this its change will be here. So it is going to get us the 50. You can play around with this one. Next, mutators and accessors. So we need to use the mutators, can apply logic invariant. So if you want to use some logic invariant, even the constructor or the member variables, so we need to use the mutators. So we have a set number, and we have the number here. Set honor, we have the honors, amount, set amount. Similarly, accessors can be constant. So if it is an accessor, then these must be constant here. So we should not skip these constants. Otherwise, these functions can accidentally modify, and our results will be incorrect. And if regarding the arguments here, so if we have the function which are mutator, so if we are getting the reference here, then we need to have a constant. But if these are you're receiving these values by copy, then you may not have these constants. So we have three access modifiers: public, private, and protected. Public is available to everyone by using the direct member access operator dot. Private is only to that member variables or also to the friend function. So you can declare an external function as a friend function of a class. You can say that in the class, you can say that this function is my friend function. So if it's a friend function, then that friend function can access the private data as well. But if it's a protected, protected is similar to private. Consider protected as a private, but the member function or friend function, additionally, subclass or derived class can also access those, but not the subclass or derived class can't access the private, but protected can be accessed. So we have, for example, a bank account class, and we have a balance which is private. We have an account number which is protected. So we said account number protected because all the child classes can access this account number, right? But the balance should not be accessed. Balance should be accessed. Each child class of the bank account, which is the savings, maybe checking account, loan account, can access the loan number of or account number of the bank account, but we can have another account numbers also. The idea here is that account number, the way this class is written currently, the account number is available to all the child classes and the balance is not available. And there are public functions, which is the constructor, and then we have a show account details. It's an external function, it receives this account, and it's a friend function. So since we have declared it as a friend, so it means that you can access these variables directly in this function. So we have a bank account. So we are defining now outside this class using the scope resolution operator. So we have a bank account, and we have defined and we have initialized these values, which is receiving the balance and the account number. So we are using the initializer list here to initialize the balance and the account number. So we have two member variable, balance and account number. And for the friend function is external function, which is not a member function. So no scope resolution operator required because this is a friend function, this is external, and it is receiving an account object. And since this account object is of type bank account, and this is the friend function, we have already declared in the class. So this function can access the private members using of these objects. So we can use it here like this one: account dot account number, which is the private, account dot balance, sorry, account dot account number, which is the, I think, protected, and account dot balance, which is the private. So both variables can be accessed. And in the main, so we have a my account, and we can initialize with this balance and the number, and then we can say show account details of this object. We can directly pass. We can't use here dot operator, but the show account details can use the dot operator and can display in this main.